I say engines. In this video, we cover the portions, the principle of working of 4-stroke diesel engine and 2-stroke petrol engines. First one, the working principle of 4-stroke diesel engine. A 4-stroke diesel engine works on diesel cycle. Hence, it is also called as diesel cycle engine. The working principle is similar to that of 4-stroke petrol engine, except a fuel injector is used in the place of spark plug, and only air enters the cylinder during the suction stroke and gets compressed in the compression stroke. First stroke, suction stroke. At the beginning of the suction stroke, the piston is at the top dead center, that is the TDC, and is about to move towards the bottom dead center, BDC. At this time, the inlet valve is opened and the exhaust valve is closed. The downward movement of the piston produces suction or vacuum in the cylinder. Due to this pressure difference, the air from the atmosphere is drawn into the cylinder through the inlet valve. When the piston reaches the BDC, the suction stroke ends and the inlet valve is closed. The suction of the air takes place at atmospheric pressure and is represented by the line 1 to 2 on PV diagram. With this stroke, the crankshaft rotates through 180 degree or half revolution. The energy required for this piston movement is taken from the battery or cranking the engine. Compression stroke. During the compression stroke, the piston moves from BDC to TDC. Both inlet and exhaust valve remain closed, as shown in the figure 2. As the piston moves upward, the air in the cylinder gets compressed, due to which the pressure and temperature of the air increases. The compression process is adiabatic in nature and is shown by the curve 2 to 3 on PV diagram. When the piston is about to reach the TDC, diesel oil is injected in the form of fine spray into the hot compressed air by a fuel injector. Combustion of fuel takes place at constant pressure as shown by the line 3, 3 to 4 on PV diagram. Since combustion of the fuel takes place at constant pressure, 4-stroke diesel engines are also called as constant pressure cycle engines. With this stroke, the crankshaft rotates by another 180 degree or half revolution. The energy required for this piston movement is taken from a battery or cranking the engine. Since the heat of compression ignites the diesel injected into this cylinder, diesel engines are also called as compression ignition engines. Third stroke, power stroke, or it is also called as expansion stroke or working stroke. During this stroke, both the valves will remain closed. As the combustion of the fuel takes place, the burnt gases expand and exert a large force on the piston, causing it to move rapidly from the TDC to BDC. The force is transmitted to the crankshaft through the connecting rod. As a result, the crankshaft rotates at high speed. The crankshaft then transmits the power through the clutches, gears, and other transmission elements to turn the wheel of the vehicle and cause it to move. The expansion of gas is adiabatic in nature and is shown by the curve 4 to 5 on PV diagram. Since the actual power or work is produced by the engine in this stroke, it is also called as power stroke or working stroke. Also, expansion of gases occurs during this stroke and hence the name expansion stroke. Exhaust stroke. Towards the end of the expansion stroke, the exhaust valve opens while the inlet valve remains closed. A part of the burnt gases, due to their own expansion, escapes out of the cylinder through the exhaust valve. This drop in pressure at constant volume inside the cylinder is represented by the line 5 to 2 on PV diagram. The exhaust stroke begins when the piston starts moving from the BDC to TDC. The energy for this stroke is supplied by the flywheel, which it had absorbed in the previous stroke. As the piston moves upward, it forces the remaining burnt gases to the atmosphere through the exhaust valve. The exhaust taking place at atmospheric pressure is shown by the line 2 to 1 on PV diagram. When the piston reaches the TDC, the exhaust valve closes and the working cycle is completed. In the next cycle, the piston starts moving from TDC to BDC. The inlet valve opens, allowing fresh air from the atmosphere to enter into the cylinder, and the process continues. Thus, the four different stroke or one working cycle is completed when the crankshaft rotates through 720 or 2 revolution of the crankshaft. The next topic is the working principle of two stroke petrol engines. First, let us understand what is the two stroke engines. The working cycle will be completed in 360 or one revolution of the crankshaft rotation. Thus, power is available in every revolution of the crankshaft. In two stroke engines, there are no separate suction and exhaust stroke. Instead, they are performed while the compression and power stroke are in progress. The two different strokes are performed are named as downward stroke or power stroke or first stroke and upward stroke or compression stroke or second stroke. The engine to be designed without walls. Instead, the cylinder was provided with openings called port. These ports act as walls and are opened and closed by the movement of the piston. There are three ports in two stroke engines as shown in the first figure. They are inlet port through which the charge enters the crankcase, exhaust port through which the burnt gases are discharged out of the cylinder, transfer port through which the charge is transferred from the crankcase into the cylinder. When the piston is at TDC, the exhaust port and the transfer port are closed, but the inlet port will be opened, as shown in the first figure. When the piston is at BDC, the exhaust port and the transfer port are opened, but the inlet port will be closed, as shown in the second figure. Based on the type of fuel used, two stroke engines are also classified as two stroke petrol engine and two stroke diesel engines. However, two stroke diesel engines are not in wide use in today's applications. Let us take the working principle of two stroke petrol engine. The two stroke petrol engines works on the Otto cycle. Per stroke. It is also called as power stroke or downward stroke. To begin with the working cycle, let us assume the piston to be at the TDC as shown in the first figure. At this position, the air plus petrol or charge that has entered the cylinder in the previous cycle is compressed to high pressure and temperature. In the meantime, the inlet port will be opened, and as a result, fresh charge enters the crankcase as shown in the first figure. The exhaust port and transfer port will be closed. It is also shown in the first figure. The compressed charge in the cylinder that is shown in the above the piston head is ignited by means of an electric spark generated by the spark plug. As the combustion of the fuel takes place, the burnt gases expand and exert a large force on the piston, causing it to move rapidly from the TDC to BDC. This force is transmitted to the crankshaft through the connecting rod. As a result, the crankshaft rotates at a high speed. The crankshaft then transmitted the power through clutches, gears, and other transmission elements to turn the wheel of the vehicle and cause it to move. Meanwhile, when the piston is pushed downwards by the expanding gases, the moment of the piston from the TDC to BDC uncovers the exhaust port as shown in the second figure. A part of the burnt gases, due to their own expansion, escape through the exhaust port to the atmosphere. Further, downward movement of the piston uncovers the transfer port. It is important to note that during the downward movement of the piston, the charge present in the crankcase is compressed by the underside of the piston. The pressure thus exerts causes the charge from the crankcase to rush into the cylinder through the transfer port as shown in the second figure. The pressure charge enters the cylinder and drives away the remaining burnt gases through the exhaust port. Thus, the exhaust of burnt gases take place while the power stroke is in progress. When the piston reaches the BDC, the downward stroke is completed, and with this, the crankshaft rotates by 180 degree or of revolution. Second stroke or upward stroke or compression stroke. During the upward stroke, the piston moves from BDC to TDC. As the piston moves upwards, it covers the transfer port, thereby stopping the flow of fresh charge from the crankcase into the cylinder, as shown in the third figure. Further movement of the piston covers the exhaust port, and thereafter the actual compression of the charge begins, as shown in the fourth figure. In the meantime, the inlet port opens and the upward moving piston creates suction or partial vacuum in the crankcase, due to which fresh charge from the carburetor is drawn into the crankcase through the inlet port. Thus, the intake of fresh charge take place while the compression stroke is in progress. When the piston reaches the TDC, the upward stroke is completed, and with this, the crankshaft completes 360-degree or one revolution. Thus, one cycle is completed. In the next cycle, the compressed charge in the cylinder is ignited by the spark plug and the process continues.